Let's start. Where we'll be starting with signals and systems, and in this particular lecture, I'll be explaining you the concepts of convolution and shifted signals and properties of convolution. And lastly, but one question on Fourier transforms. And I've solved all the questions which have appeared in the previous 2025 paper. So we'll give you a know-how and many deep concepts also. So periodic and non-periodic signals. So definitely you do know any signal which repeats after a certain interval of time. Okay, so for example, if you have a sine signal, right? So sine signal will repeat after an interval of time. See here. So this is 0, this is 180 degrees, this is 360. So sine anything 30 plus n pi, right? So if it is 1 pi, so sine repeats after an interval of n pi degrees. Same way happens with other signals as well. So this is what a signal is, a periodic and a non-periodic signal. And basically these definitions for cos it is 2 pi. Okay, so same way, let's move to the next part of the question. The question that are important is basically how do you determine, suppose you are having two signals. Okay, one signal is having a periodicity, let's say a time period of, you have like a signal like this cos 3 omega and sine, let's say 4 omega, and it has a time period of t1. That is your, if you just compare its values, omega t1 is equal to 3 omega. So t cancels, so t1 is 3, right? And same way t2 is 4. So in order to calculate the complete periodicity of these signals, you just need to see 3 and 4, you will just calculate the LCM. But in case you have a signal like this 4 and 18, in that case LCM you will calculate by multiplying the greatest, multiplying these two signals T1 and T2 and choosing the greatest common divisor. This is the method. This can be also applied in the amplitude. Okay, so here you get, this is the total periodicity of the signal. Now, what we are more interested in, what is an energy signal? Now, if I'm talking about an energy signal, an energy signal's average power would be equal to zero. Okay, so a energy signal can be like a pulse, a signal that exists for a short time and dies after some time, whose total energy is finite. But if you look at an impulse function, right, it also appears, but its total energy is infinite because when it appears at t is equal to 0, it carries an infinite energy. Hence, impulse function is not an energy signal. It's neither energy nor power signal. So total energy has to be finite. The example for this is a decaying exponential signal, any finite duration signal, or a rectangular pulse. Now, basically, a power signal is, think of like AC supply and runs forever and never dies. Okay, energy keeps on increasing with time. Total energy is infinite. Now, any sinusoidal signal, okay, or periodic signal, or a constant DC signal, right? Its energy is going on, okay, it is infinite. So, the mathematically energy signal from time is equal to prehistory to the sky, infinity, I say sky, and minus infinity is like the patal loop there, okay? And if you are carrying this signal over dt such that your average power of the signal comes out to be zero, whereas energy is finite, such signal is called as energy signal. Okay, average power of the signal, power would be finite. Okay, okay, so average power of a signal is given by this expression. Okay, minus okay, this expression can be slightly modified also. Like if you write this expression 1 by 2t is there, na? So you're moving from minus t to t, right? When you're moving from minus t to t, if it is equal minus 0 to t, you move, then you move from 0 to t. If this 1 and 2 are equal, so you can say that minus t to 0 is equal to 0 to t movement. So you can just write this as, instead of 1 by 2t into 2 into 0 to t. This 2 cancels. So you can also write the power signal as 1 by t x of t square 0 to t, which I have written in the next slide. Okay, so here you can see here, this is your minus t to minus t. So I can write this as in this form, right? 1 by t 0 to t. Okay, then x of t square dt. Okay, so classification table, signal type and all that. See, finite duration. Okay, energy signal will be having finite. Okay, power of energy signal would be 0. Decaying exponential is finite, so power is 0. Periodic signal is having infinite energy and finite power. So remember, a power signal is having infinite energy, whereas an energy signal is having an zero power, average power. Okay, so this is the case scenario over here. The table I've already made. Okay, let's go to the next slide. Okay. One of the questions has been previously. Let me move here. Okay, nothing has been written in this slide. Slide number 4 was this. Okay, then I'll jump to the okay. Now, gate one question is asked: a continuous time periodic signal x of t is given by if t is the period of x of t, then now 1 by t 0 to t. This is a common. See, normally your energy expression is 1 by 2t, right? Then minus infinity to infinity. Okay, then this x of t square dt, right? But we can break this down. Now I just showed you gate chooses this expression 0 to t xt square dt, right? Because this 2 and 2 gets cancelled. So this is asking to calculate the average power. The normal method is, if I do with the normal method, it will take me so much time. I have to fetch in this value x of t here, 1 by 2 cos 2 pi t plus 2 cos 4 pi t plus then whole square. It would be a lengthy process. Now, the trick here is, instead of integrating, I'll check this. This is a DC value of this signal, okay? And whatever the other values are there, this is my AK value. For this, it's a 1 minute process. We'll write average power formula like this: A naught square plus summation of AK square by 2. Average of cos square over one period would be half. Why this formula also comes is because it would be half. I'll show you how it comes. Like for example, you just take an example of cos square omega t. So average period t would be 2 pi by omega. So average is 1 by t 0 to t cos square omega t. Cos square omega t can be written as cos square theta can be written as 1 plus cos 2 omega 2 by 2. Just substitute, just integrate it here, this part and this part. Now, if you see for this part, cos 2 omega t integration is sine 2 omega t by 2 omega. 2 omega out, then sine 2 omega t minus 0. So you just put the value sine 2 omega t. Okay, what is omega t equal to? From here, omega t is 2 pi. So sine n pi is 0 and minus 0. So this part of the equation becomes 0. The remaining part is only this. So this is your half t into, okay, this would be t. So this is half. So any function of cos would be equal to half. That's why we are utilizing this formula a naught square. So here we will be having 1 square plus ak square summation. So here a is 2. So 2 square divided by 2 plus again this ak here is 2. So this is 2 square divided by 2. If it was 3, then 3 square divided by 2. If it was any other value, then that 2 square divided by 2. Straight away you will get the value. So you just see 2, 2, 2, 2 and 2 cancel. So you have 2 plus 2 plus 2, 6, 6 plus 1. So power of this signal would be equal to 7. Just okay, for 2 marks lollipop question they have asked. Okay. So this was one of the questions that they have asked in the gate examination. Okay, this also I have broken down for your understanding. If you want, avoid this. Okay. Now, what is a gate trap, for example? If x of t is given sine t, okay, if you see it's a periodic signal, right? Its energy should be equal to infinite because sine t is a power signal, right? And power of the signal would be a half. All sinusoids, like sinusoids include your cos and sine, okay? In both the cases, if you do sine 2 omega 2 integration, that will also come down to half. Now the second trap is here: a decaying exponential signal which looks like an energy signal which is multiplied by a unit step signal. So here basically the energy looks finite and power is equal to 0. Remember, the decaying exponential signal are energy signals, okay, multiplied by ut. The value of this ut, now you should not get confused. The area under the ut, whenever any multiplication is with ut, it means you are just multiplying it with 1. So e power minus t ut is as good as e power minus t. Okay, the trap 3 is they have just given a constant DC signal. Okay, constant DC signal. So constant DC signal is again an power signal, which I've already mentioned. So for a DC signal, the value is just a square. So if they ask you to calculate its power, it would be 25. Now this signal cos t cos 2t. So how do you go about this? So cos function will be having half, okay, and this will be having half, right? Half. So the energy of it would be, you have to square it down, half square plus half square, okay. So this will give you 1 by 4 plus 1 by 4. This would be the result, okay. So this would be equal to your sorry, not 1 by 4, 1 square, okay, a square by 2, right? A square by 2, so it would be 1 by 2 plus 1 by 2. Its power would be equal to 1, not 1 by 8, okay. So it is no, because your a value is 1 here, right? If it was some value there, if it was like 3 cos t plus 5 cos 2t, then the power would have been 9 by 2 plus 5 by 2. That, in this scenario, it would have been 14 by, yeah, 9 by 2 plus 25 by 2. Okay. So let me take some good values, 10, so that we get a perfect answer. Uh, 10 and 36. How can I make this? Let me take this as 4. So it will become 16, right? 16. And 20 I need, right? 20 I need. So let me keep this as 5, 25 for a perfect square. Okay, whatever, let it be. So that means if you are having a signal 4 cos t plus 3 cos 2t or whatever it is, this does not matter. Okay, this does not matter. Only thing that is mattering is these values. So here you see 4 square by 2 plus 3 square by 2 in this case. So this will give you a reading of 16 by 2 plus 9 by 2. The entire value would be 25 by 2. So the power of the signal would be 12.5. Okay. So this type of a signal is a power signal, not an energy signal. So remember, in case of an energy signal, the energy is finite, whereas average power is zero. Okay. Whereas in case of a power signal, energy is infinite, average power is finite. So this is the only difference. Okay. So when DC signal, see here, cos t, see in this case, if you are having a DC signal, then 2 square plus here 1 by 1 square by 2. So in this case, it would be equal to 4 plus half. That would be equal to 0.4.5. So DC signal, you directly no need not to divide by 2. Okay. Golden rules, remember this, periodic signals are power signals, and DC term you scare fully, and DC term is also an power signal, okay, because its energy would be infinite, okay. Now each cosine amplitude square divided by 2, that you have to do, okay. What about an impulse signal? It is neither energy nor power signal, remember this, okay. So normally energy signal equation is this, and average power you will get by this expression. Okay, let's move to the next. Okay, so what is impulse basically? Impulse is zero everywhere except at t is equal to zero. It goes to infinity. Its amplitude goes to infinity, not one. Unlike the unit step, it goes to infinity. Its area is one. Okay, so if you just apply to this impulse response for energy calculations, so you just put an impulse is a narrow pulse. So what we do is we just approximate it with a signal, the small signal 1 by e square by e. Okay, so if you just pick it from minus infinity to plus infinity, so this 1 by e from minus infinity to plus infinity will tend to zero. Okay, hence it is not an energy, neither energy nor power signal. Now, the important definition here is what is convolution. In signals and systems, basically, if we ask, if let's say I give you an input to a system, what output I'm going to get? If you know the system's response to basically one particular signal, let's say you are a black box here, okay? You are a black box. I just punch you, okay? Now your response comes. You go home, cry, and sleep. Okay, what is my conclusion? My conclusion is that Jasira is a docile person. Okay, she does not has any gets. Now, if you give it back to me, what does that reflect? That reflects basically what means it's an aggressive person. Next time I have to pay attention. So any system which completely characterizes this signal, right? This is your input. Input is a signal. Okay, this you itself are a system, and whatever the response that I'm going to get out from it, that is my output. Okay, if this input which completely characterizes the system, in signals and system case, this input is the impulse function. So in other words, in a popular literature, we can say in my language, impulse response completely characterizes the system. It gives the complete classification inside out of any system. Okay, so that's why the impulse response is very important. Okay, impulse response in the continuous time domain is zero everywhere and infinite at one point. T is equal to zero, is area is one. Why impulse is powerful? Any signal can be written as a sum of shifted impulse, each impulse scaled by a signal value. Any, be it ramp signal, be it unit step signal. So, how you can do is this, see, what I have written x of tau and multiplied it with the impulse of t minus tau. So, all signals are primarily basically collection or a summation of impulse signals. So mathematically, how do I express convolution? This is the formula for convolution. So this is x of t is my input, okay, and h of t is my impulse response to it, impulse response. If I give a delay in the input and this x of t, okay, this is the mathematical data. So here in LTI systems, h of t is output when input is lambda of t, okay. So when I give an input impulse response, okay, and h of t, this is the DNA of the system. Once you know h of t, the system is completely known. Now comes the idea of the convolution. Input basically is sum of impulses. System response of each impulse is known. Output is sum of shifted impulse responses. And adding this up will give me the convolution problem. So you see, this is multiplication here. X of n cross h of n is given as x of k, h of n minus k. So how do you relate this convolution process? Now I'll explain you this. Now one gate problem has come over here, okay, when it is consider the LTI system as when output, this is your output, is equal to sx of n. So lambda of n. Now see here, let lambda of n be equal to 1 n, okay, 1, okay, okay, only 1, okay, ठीक. One, when it, see, this means it belongs to, okay, belongs to, that means the value of lambda, when your n value is 0, h of 0 value is 1. When your n value is 1, h of 1 value is 1. This is the amplitude, this is the amplitude, okay, amplitude. And when your n value is 2, your h of 2 value is 1. But if n value is 3, h of 3 value is 0, correct? And so on and so forth. If h value was equal, n value was equal to minus 1, h of minus 1 value is also 0. So you are interested in only these three cases. Okay. So here that means h of n would be, see, there is a definition for this h of n calculations. So any, see, this is the sum of shifted impulses. H of n can be written as h of k lambda n minus k. So h of k value is basically summation, right? So minus infinity, but here you are in this domain, you are minus infinity to infinity, but you are having signals only at uh, n values of n is equal to 0, n is equal to 1, and n is equal to 2. So you will only start, because all the other values the signal is 0. So you are putting h of 0 value 1, okay, so h of 0 lambda of n minus 0, h of 1 lambda of n minus 1, h of 2 lambda of n minus 2, right? So that is h of 0 lambda of n minus 0, h of 1 lambda of n minus 1, h of 2 lambda of n minus 2. So this is where you are getting this, okay? So now output is asked. Output is nothing but y of n into star of lambda of n minus z, h of, or you can directly write this as here, let me show you, okay. So you can use this. So once you get this h of n value over here, okay, this h of n value here, you can use the impulse response property, that is simple convolution. Y of n is just the multiplication x of n into h of n. So h of n you got, okay, x of n into h of n. And you do know your h of n is, but h of n is only comprising of the impulse responses. So its area is 1. So that means if you are multiplying this x of n, right, with lambda of n, so that means x of n into lambda of n value is going to fetch you x of n. But if you do x of n into lambda of n minus 1, so it will give you a shifted x of n minus 1. And if you do x of n into lambda of n minus 2, it will give you a shifted x of n minus 2. That's your output. So here you see, this is the output. B part would be your answer for this. Okay. So let's move now. Okay. Now let's see one more question in the gate they have asked. Consider a continuous time signal where u of t is the continuous time unit step function. Let lambda of t be the, okay, be the continuous type unit impulse function, the value. Okay, very good. So here, if you notice this function, okay, there's the properties of impulse response and convolution is very important. Now you need to understand the impulse inside the signal. This you have to integrate, right? So the impulse inside the signal is lambda of t plus 3. Oh, sorry. What is this called? I don't know this. This is lambda or what? Something. Okay. Lambda of t plus 3. Okay. So now remember one thing. You need to rewrite this in this form. This lambda of t. So this you need to rewrite it in this form. T minus a. So in order to rewrite this t plus 3. So t minus of minus 3. So that means your impulse is located at t is equal to minus 3. Right, from this equation this t value you found as minus 3, just resubstitute back this t value into the equation, put t is equal to minus 3. So this would be minus minus 3 ka square, u of minus 3 plus 4 minus minus 3 minus 4. So you get this u of 1, u of minus 7, this is minus 9. Now if you look at the property of u of t, right, u of t holds good for, okay, 1 and t is greater than equal to 0 or 0. Means u of 1 value would be there 1, correct? But u of minus 7 value is 0. So the answer to this would be minus 9 into 1, minus 9. Now suppose in this question, if they are asked instead of this 3 over here, they had put t of minus 5, right? Then, then first of all, you had to put lambda of t. This is minus 5 given over there, right? It's already in that form, right? Okay. So here plus 3 was given, right? If this is given in this form and the same question is given here, right? So let's say, yeah, let's say this is as minus 5. First, you have to put this in this form, lambda of t minus a. So that means lambda of t, okay, minus of minus 5, correct? No, but this would be wrong. Not, so let's say t plus 5 is given. I'm sorry. T plus 5 is given. In this scenario, what is happening? So this is becoming your minus 5. This value is becoming your minus 5, right? Okay, so here the value will become u of 1 minus u of minus 9. Okay, okay. So u of 1 value is equal to again. So the answer would have been equal to your minus 25 into 1. Minus 25 would have been the answer. Suppose in any chance your t value, your this a value was equal to, let's say this a value, okay, lambda t plus 3. So suppose this you found this point, okay, t is equal to minus 5. In that scenario, what you would have done? Or t is equal to plus 5. In that case, t would have become plus 5 when, see, lambda of t, right, minus of, okay, minus 5, right? This is the case, minus of minus 5. Okay, in that scenario, the equation you just try to do, okay, you try to do like this case I did, na? Try to solve on your own because I have limited space here. Now, what does actually convolution do? Four step, basically, if you have been diagrammatically asked, this I'll show in the next class. Flip one signal, okay, write x of minus t. So if x of t is like this, okay, x of minus t would be vice versa. It would be symmetric around the x-axis. There is a difference between x of minus t and minus x of t. Minus x of t would go down, right? For minus x of t, see, this was on top, no? For minus x of t, it will move down, right? This is the moment. It will be symmetric around x-axis if the function is unit step. This is minus x of t. This is your OG signal, original signal, and this is x inside the parenthesis minus t. Now flip one signal, write x of minus t or h of minus t. Usually you take this h of t, which is the impulse response of your input, okay, and shift it by a value t. such that you can write this as h of t minus t, then multiply both these signals with the input, add everything, integrate. If it is a continuous time, it's a discrete time, then you sum these signals. So physical meaning of this convolution is, think like this: x of t asks for what is applied now, h of t answers how does the system react over time. So convolution basically answers how much the system past reaction are still applicable, okay, or affecting the process. Convolution works only with the LTI system. Linearity allows this scaling and addition, and time invariance. Same responsive. So a convolution signal will apply for linear time invariant signal. Now, real world analogy, if you have to understand, suppose there is an echo in a hall, you are clapping, sound spreads everywhere and slowly, okay, this is like your h of t, okay, you speak continuously and you're like, what you hear is many echoes are overlapping, plus the clap and everything noise, basically convolution of speech with the echo response. Okay, convolution is the whole process that you're going to hear. Any signal can be built by adding infinitely many shifted impulses. So any signal, ramp, be it unit step, be it, okay, what you have to shift it and you have to build it. Now, relationship between the unit step, this you know, impulse response is a derivative of this. Unit step would be equal to 1 by d, right? If I take this side 1 by d, 1 by d is given as, if you from the past to the present value, okay, lambda of t dt. This means unit step is formed by adding all impulses from minus infinity up to the time t. Again, this minus infinity up to this unit step can be also written for, because see, minus infinity value you don't know. Okay, like this you can write 0 to infinity lambda t minus t. This interpretation for every t greater there is an impulse. Okay, all impulses have a weight of 1. Adding them creates basically step. Okay, this is the meaning of this. Now, ramp response, ramp is given as t into u of t. Differentiation of d by dt of ramp will give you unit step. Okay, and so ramp is integral of step, and impulse response is basically differentiation unit step, which I already showed. Differentiate this, get the unit step, double differentiate the ramp, get the impulse. Okay, so primarily these are the processes that are involved here. Now, actually, if you are integrating this, right, unit step, you can just write this lambda of t is equal to the differentiation d by dt of u of t. Now, in the discrete time domain, the value of this function would be 1, right? So 1. So infinity minus infinity. So this would be u of infinity minus of this minus infinity. So for unit step, u of infinity value, if it is a unit step function, so it is infinite till infinity, the amplitude is 1, and minus infinity, the amplitude is 0. So this is 1 minus 0. So basically, this shifted version example is also given. If you are shifting this, so the same shift will be here also. So this is impulse response from the step. How do you get differentiated step response from the impulse integrated? Now, if in the discrete time domain, this is in the continuous time domain. In the discrete time domain, lambda of n is u of n minus u of n minus n, and step is basically u of n. This came from this same process, right? U of n is equal to k. This process we applied in the previous uh, class also. So basically, in the gate, these are the very important properties that you need to remember. Okay, this for the ramp, this for the unit step, this for the impulse function. I'll show you how we are going to solve some questions. Okay, now convolution I already explained you. This is your output, and you're just multiplying your input with the impulse response. And so this is written as, this is the mathematically it is given, this is in the continuous time domain, and this is in the discrete time domain how it is given. Here x of t is the input signal, h of t is the system's impulse response. Okay, y of t is the output signal. So output signal is system's impulse response into input signal, right? Convolution tells us, or okay, how the system reacts to an input, basically. Key concept, I told you, flip the signal, shift it, multiply, integrate. If it's discrete, then add, sum it. What is important, basically area of convolution basically multiplies the areas. Impulse response can be known, output is the convolution. LTI system, entire behavior from systems impulse response can be characterized. Now there are certain properties with respect to this. If you are convolving, Okay, two systems impulse response with one input. So this is linear also, x1 plus x2. Then time shifting, x of t minus t naught h of t will result in the same, in the shift in the time in the output, right? This is the output, this is the input, right? And what is this? This is the system's impulse response. Systems impulse response. Okay, now let's go. Okay, now this already I have explained you. Now one more important property is they are asking Bibo stability. When you check and systems impulse response, this is asked in the gate. So if you are integrating infinity h of t dt such that this value, if this value comes as finite, then the system is Bibo stable. Okay, Bibo stable. There they have mentioned it is less than infinity, right? If that means it is okay. Now step constant, step function, constant or ramp function, they are not Bibo stable. If you are giving like this h of t is equal to u of t into d of t minus infinity to infinity. Okay, if you see this, whenever u of t is given, you just take the area dt minus infinity to infinity. This will become t, and you just substitute the values minus infinity to infinity. So infinity minus of minus infinity becomes to infinity. That is infinity only. So this is not less than infinity. Okay. Now, if you have to check casualty for a system, h of t would be equal to system's input response would be equal to 0 for t lesser than 0 for the previous values. Okay. And memory, so you know that these systems which have direct relationship like V is equal to IR type. So these are memoryless systems. Now, any other important property of Fourier transform is that h of 0 is equal to 1 by 2 pi, or h of 0 is equal to 1 by 2 pi minus infinity to infinity h of j omega d omega. Okay, this is the Fourier transform property. Okay, and these are other shifting properties of impulse response. X of t t minus t dt is given as x of t naught. Okay, this is given, and x of t lambda of at minus b is given as 1 by a x of b by a. This is also very important property which is not applicable here, but in other questions it can come. So these properties, see, gate does not ask you, it checks your sharpness. And rest I told you energy and power in one line. Basically, energy will be finite. Energy signal is having a finite energy and average power zero, whereas power signal is having infinite energy, like a sinusoidal signal and this thing. Okay. And this question to be just now solved. Okay. Now let's see. Okay, one very good question has been asked. Two given signals are given. This has been asked in the GATE exam 2025 only. You can just check the made easy thing that I've sent you. Okay. So given this means amplitude is equal to 1. So and time is belonging to 0 comma 1. That means when your time is usually on the x-axis, when it is 0 and 1, the amplitude of the signal remains 1. Correct? The amplitude of the signal remains 1 till here. Okay, till 0 to 1. And that means when time lies between 0 to 1, your amplitude of the signal is 1. Then what it is saying? Your amplitude of the signal happens to be equal to 2 minus t when the time is lies between 1 to 2, right? So your 1 to 2 is this process, right? 1 to 2 is this process. So that means when you put t is equal to 1, your amplitude here will become 1. That is good. So at 1, it is 1. But if you put the endpoint t is equal to 2, what happens to your amplitude? 2 minus 2, 0. That means at this is only possible if it goes like this, you know, because at 2 it is happening like this, at 1 it is happening like this. What about 1.1? So at 1.1, what would be the value? 2 minus 1.1, zero point 0.9. Same way, zero point 0.8. So this is your point amplitude here is 0.9, 0.8, 0.7, zero point 0.6, zero point 0.1 till it goes to 0, right? So it's so now you saw this region. Now, instead of doing the mathematical process of convolution, you can use a gate trick basically. You can use this y of t dt. You just need to calculate this output of this y of t. That would be just the area of signal of x1, signal of x1 of t into area of signal of x2 of t. So this signal is a rectangular signal. Its width is 1, height is 1, so it would be straight away 1 into 1. for x1, correct? And what about the other part of the signal? 1 and 2 is mentioned here. This is a triangle, half base into height, half 1 into 1. So this signal length would be 1 plus zero point 0.5. So this gave you 1.5, right? Now let's see x2 of t. Have they mentioned? Okay, x2 of t is here. So x2 of t happens to be equal to what? 0. No, t. Okay. So x2 of t happens to be equal to t between 0. Okay, let me just check. Uh, yeah, here x1 of t, so I have explained you x2 of t. Okay, okay. X2 of t happens to be, so this area we calculated. Was the signal that, okay, okay, here it is. So x2 of t is basically now t is equal to 0, less than equal to, less than equal to. So that means when your t value happens to be equal to 1, correct? T value is 0, this the signal is 0. Okay, that means the value of the signal is equal to t. That means if the time is 0, this is 0. If the time is 1, it is 1. So this means this is moving like this, 0 to 1, right? And the second part of the signal is 2 minus t, which is obviously like this. So these are two triangles. Okay, so you just calculate this half base into height, half base into height. Half base is 1, height is also 1, plus half base. So this area would be equal to 1. And the previous area was 1.2. So x1 into x2, x1 of t into x2 of t you do, that will give you 1.5 into 1. So this y of t would be equal to 1.5 for this. Okay, these are simple tricks that we'll be utilizing. Okay, only 5 minutes are left. I'll just continue in the next session, because then